Hello, Physics Nation. I'd like to do a problem from Khan Academy on the one-dimensional kinematics quiz. A rabbit's trying to cross the street. Its velocity v as a function of time is given in the graph below, where rightwards is the positive velocity direction. So we're keeping track of the rabbit's motion as time goes on. It's accelerating. It's moving away from the origin, getting faster, 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 and then it hits its top speed at 1 second. Still moving away from the origin, but then it decelerates down to 0 at 2 seconds. And then it reverses direction and accelerates towards the origin for the next second. So we're trying to figure out how far this rabbit goes in these 3 seconds while it's accelerating, decelerating, and then reversing direction and accelerating. Seems impossibly complicated, right? Well, there's a little trick. Rather than thinking of speeding up, slowing down, and then reversing, pardon the scrolling, we're going to find the average velocity for these two different regions. So if you go from 0 to 5, you can pretend you're moving at 2.5. So this is the first average velocity equation. It's right in between the initial and the final. If you start at 0 and you end at 5, you can pretend you're moving at 2.5 meters per second for this entire 2-second interval. Well, then all you do is multiply average velocity by time, 2.5 meters per second, by this 2-second interval here, 0 to 2 seconds, and we moved 5 meters in this first region while the rabbit was moving away from the origin. And we simply do the same trick, except it's for the second region from 2 to 3 seconds. Right in between 0 and -5 meters per second is -2.5 meters per second. So we're going to pretend the rabbit is moving towards the origin with a constant velocity during this 1 second interval. And again, the same trick. The second average velocity equation is just average velocity multiplied by time, -2.5 meters per second multiplied by the 1 second interval means the rabbit moves -2.5 meters towards the origin. And then you just do the positive 5 meters displacement plus the -2.5 meter displacement, and you get 2.5 meters. Khan likes to emphasize that it's the area under the curve. And this concept is actually going to come up over and over again in integral calculus when you get to that. So simple trick, pardon my scrolling, change accelerated motion into constant velocity. And then you just do distance equals speed times time, basically. Thanks for watching. See you in the next video.